Hello, in this video I want to demonstrate how can you use individual Excel function to calculating those numeric descriptive to your data. And also the most important, I want introducing how can you calculating the 5 number you needed to creating the box whisker plot. Later on we're going to look at in next video. And also how you use the second approach to identify outliers. So we learned how to use the z-score to identify outliers, but the other approach is based on the interquartile range. Okay, so let's start together. So first, let's look at the statistic we learned that you can use to measure the central location or central tendency of your data set. So the three we are learning here is mean, median, and mode. Three of them are able to describing the central tendency of your data. And we emphasize for the mean and the median are the one you can use to measure the numerical variables or quantitative variables. For the qualitative, you are not able to calculate mean and median, so therefore you will use the mode. Okay, so let's look at the mean. For the mean, we are using the formula called average. And then once you type average, and then you are able to use the formula average, something you need to remember, equal average, and then select your data set. Keep in mind, please do not include in your title. And once you select it, and close the parentheses and push enter. So that is the mean or average of my starting salary. So that is $37,292. So the second is called a median, and we are typing the whole word equal median in the parentheses, and then select the data set from A2 to A26. Okay, so if you are thinking I'm going a little bit too fast, like I said, when you're watching this video, you actually can slow down by looking at there's an icon on the gear. You can slow it down if you want to slow down. Okay, so the median for this data set, starting salary, this variable is 41,400. Okay, and for the mode, we type in mode. And we want to focus on the single mode, SNGL, and the parentheses, SNGL stands for single. And then we are selecting my data. And then close the parentheses. That gives me 7,500. And sometimes you might get nothing here, like have the pound something. It does not mean your code is wrong. It just means there is no mode. Remember, we are looking for the single mode. That means we are looking for the number that show up the most. But in some situation, you might have 2 numbers show up the most or 3 numbers show up most. If those are the situation, the mode here will give you a pound, like almost like arrow. It does not mean you creating arrow or your formula is wrong. It just means you do not have mode in your data set. Okay. So above 3, mean, median, mode are the one we use to measure the central tendency or central location. Now we move on to look at the statistic that you can use to measure the dispersion or variability of your data set. So first we're going to look at is the sample variance, but also I will introduce in the population variance and the sample standard deviation and also population standard deviation. So the data set we're using in this class are considered as the sample data because I have no access to any population data, right? So for the sample data, and you're going to use the sample variance, what you need to type is equal ver dot s. So S stands for sample, and then parentheses, and then you will select the data. Again, do not include in the label. And after you do that, and you can push enter. So that is my sample variance. It's huge because it's the square of your differences, right? Now we can calculate a more popular way to measure the variability, which is standard deviation. And the formula we use equal STDEV dot S, and then parentheses, and then select your data set. And then close the parentheses, and then push enter. That will give you the sample standard deviation. And then again, before I move on, so what you can do is population. So population will use the same, very similar formula. Instead of .s, we change it to .p, right? So if it's the population, so what you need to do is type equal var.p, and then same thing, selecting the data. So if the data is population, right? So that will give you the population sample variance, the population standard deviation, STDEV dot P, that'll give you the population. So P stands for population. So now you have population. Okay, again, the formula we use the most in this class is a sample. So this is the two way to measure the variability of your data or data dispersion. So the other one is range. So in order to calculate range, we need to know the minimum value and the maximum value. So therefore, I need to introduce in these two formula before we can calculate range. So for the smallest value, which is also called minimum, so which we type equal min, and then parentheses and the select data. Close the parentheses and push enter. So basically that's telling us the smallest starting salary equal to 7,000. And how about the highest salary? So we use max and close the parentheses. So that means give me $87,000. So basically the high salary, starting salary is $87,000. So now we are able to calculating the range. So the range equal to the smallest, the largest minus the smallest. Since you already calculated the max and the mean, and you can just equal and selecting the cell value and minus the mean. Okay, so that gives us the range. So the range for this data is another way to measure the variability or dispersion of the data set. It's $80,000. Okay. So before I go to the skewness, which is measure the shape of distribution, I want to move on to the other one, right? So the other one you can measure the dispersion is called the CV, coefficient of variation. So coefficient of variation, if you pay attention on the lecture, so the correlation or coefficient of variation is equal to the mean divided by the standard deviation and then times 100, right? So that is how you calculate a correlation coefficient. So basically, we already calculated a sample mean, and also we already calculated a sample variance. So therefore, we just need to follow the formula to calculating this value. So let's just do the calculation. We type equal sign. I think I would just say in the oppositely, correct? So we will use a sample standard deviation divided by mean, not mean divided by standard deviation. So it's opposite. So we're using equal to the sample standard deviation. So we already calculated. So I can just select it and then divided by my mean and then times 100. So again, this is in percentage, remember? So the coefficient of variation is in percentage. That's why we times 100. And I got 62.9% of the variation is the sample standard deviation is associated with mean. Okay, 62.9%. So this is the fourth way you can measure the dispersion or variability of your sample data, right? So 1, 2, 3, and 4. So the other one we learned is called interquantile range. So that's the fifth one that you can use to measure the dispersion of your data. However, in order to calculate this interquantile, we need to know how to calculate the first quantile, second quantile, and the third quantile, and then we calculate interquantile range, because the interquantile range is equal to the third quantile minus the first quantile, right? So therefore, let's just do it together. So the formula we're using is called a percentile dot include. So basically, we're including my median. We will calculate the first quantile. So here we will type equal to percentage, percentile, make sure include. And then after I type percentile include, and I will select my data, and then comma. And then after I select my data, so here, remember the first quantile, basically it is all the value below the first 25% of your data, right? After you sorting your data, we're looking for the first, the data that is located at lower than first 25%. So therefore, here will be type 0.25. That will give you the first quantile's value. So that is equal to 16,000. So basically, if we rank the order from the smallest to the largest value, so the 16,000 will be the cutoff where we are consider any value are smaller than 16,000 will be my first quantile within our first quantile. Now we move on to the second quantile. In the class, so the second quantile here is using exactly the same formula, percentile include, and then we are selecting from 2 to 26 here. So the second percentile is the the 50% of my data, right? 50% of data after you sort it from smallest to the largest, and then I will push enter. So it gives out 41,400. You will notice that this value are exactly the same value as my median. So it's not surprising. So this has to always be the truth. Okay. So your second quantile is equal to the median. That has to be always the case. Okay. So this is my second quantile, and my third quantile is equal to percentile include. And then I will select my data. And then after that, and I was 0.75. Remember, the third quantile is after you sort data from smallest to the largest. So the data located at the 75th location, right? 75th% location. So this gives me the third quantile. So that is 52,500. So basically, if the value is smaller than 52,500, then we'll locate that third quantile below. Okay, so now we are able to calculate interquantile range. So that is equal to the third quantile minus the first quantile. That will give us the interquantile range, and then you can push enter. So that gives us 36,500. Okay. Okay, so now we are able to obtain the one, two, three, four, five method to measure the dispersion of the data set or variability of data set. And where these three are measured the central location. And then the other one we need to know is our shape of distribution. And so the formula we're using is called, try to calculate the skewness of my data set. So the formula is spelled as SKEW. And by default, it is for sample data. So unless you are calculated for the population, then you're going to use the P1. So in the class, like I said, the data set we are handling is belonging to the sample data. So you can just use skew and parentheses and select your data. And close the parentheses and push enter. So that gave you skewness. It's 0.222903. So it is a positive value, therefore it's the positive skewed, right? So the positive skew means like this, right? The tail is, I know on my video is a little bit opposite because you need to mirroring. So basically, if you think about the long tail is a stretching to the right, right? Stretching to the right. So not surprising as you notice that the relative position between the mean and the median. So the mean is larger than, sorry, the median is larger than the mean. So so the question is, what does this positive skew means, right? So the positive skew distribution, think about the salary. So basically the tail was stretching to the right side, okay, right side. So you have a large majority area on the left-hand side. So that means indicating the most data point are clustering towards in the lower end of the spectrum, so lower. And but then we are also have a few extremely large value on the right end. And basically in this case, majority of students are earning lower starting salary, but we do have a few students are earning higher, a few business school making very high incomes. So therefore they are stretching that the right tail to the right. So that therefore what you notice that the mean value is actually smaller than the median, right? So you can notice that the mean value actually smaller than the. So yeah, therefore the positive skew, that's what we notice here. But I know some student might gonna question Dr. J because based on the mean and the median relative position, as we learned that if it's a positive skew, the mean has to larger than the median. But as you notice that it's not the case, the mean actually smaller than the median. And then this is the moment we need to think, wait, is this skewness was incorrect? So the answer is no. So the skewness here is calculated correctly, but the value here is 0.22, so it's very close to zero. It's very close to the symmetric values. And then the most important thing you notice that the mean actually end up smaller than the median, which is really odd. It's just indicating in this data set, we actually may not be able to find outliers so that the right tail, as we notice in the right skew distribution, can pull in my mean so high that it's going to be larger than the median. So in this situation, and the best way to decide if the distribution is skew left or skew right or positive skew left skew is based on the value of the skewness. Okay. And the one more thing is, after we look at the central location of the data set, the disparity or the variability of the data based on the sample variance, standard deviation, range, and IQR, interquartile range. And then also we are able to know the shape of distribution for this data set. So next I want to emphasize in the 5 number that is very important that we're going to use to creating our box whisker plot. So the 5 number are minimum value, maximum value, the median, the minimum, maximum, first quantile, third quantile, and the median. Okay, so again, the median is equal to our second quantile. So based on this 5 values, we are able to creating our box whisker plot in our next video. And before we move on to that, I also want to emphasize in the box whisker plot, we are able to identify outliers. So the way we identify outlier is that if a value in my original data set here, A, if the data is smaller than if the value is smaller than first quantile minus 1.5 times interquartile range, that data point will be considered as a very small, the extremely small outliers. And then now will be considered outlier, which belong to the smallest value range. So also if the data is larger than third quantile plus 1.5 times interquartile range, so if that data value is larger than that this threshold, we are also consider that as outliers. So for instance, in this case, if the data is smaller than first quantile minus 1.5 times my interquartile range is, do we have any values smaller than negative 3,875? The answer is no, because the smallest value is 7,000. So therefore, from this end, we don't find any outlier. How about on the higher value end? So this is equal to third quantile plus 1.5 times interquartile range. Yes, we also don't see any value is larger than 10,000, 107,250 because the largest value in this data is 87,000. So therefore, based on this criterion, we also will not find any outliers. Okay, so in the previous video, we look at the z-score method, right? So here we look at based on the interquartile, this threshold, we also don't see any outliers. Okay, so that means in my next video, when I showing you the box whisker plot, you won't be able to see outlier from that diagram. Okay, so let's move on to the next video.